Yeah, thanks. So Vince took the tough spot right after lunch, so this is maybe not quite as tough, mid-afternoon. We're going to talk about VHF stations, and actually, if you look on the schedule, I'm doing VHF, and then Stu is going to do HF, so we'll kind of do a back-to-back lineup of those two presentations. And really, we're speaking to the audience of a newer ham sort of getting started and you know, exploring options and building on their station. I think a lot of us, a lot of new technicians, for their first radio runs out and buys an HT, right? And the cool thing about that is it gets you on the air. It's a fully encapsulated ham radio station. It's got a power source, it's got an antenna, and it's got actually quite a bit of capability inside, which is pretty cool. But it's kind of a low power, limited, doesn't put out a huge signal kind of thing. So we'll talk about how to move up from there. So I'm going to talk just briefly about maybe getting a little more out of your HT, and then we'll move into a basic VHF station. Really going to focus on FM, okay? I'll make a few comments about CW, single sideband, and weak signal work, but kind of the center of the presentation is FM operating. We'll talk about power supplies, transceivers, antenna systems, and then wrap that up. That's Stu and his brother Larry when they were a kid. They were into radio at a very early age. Okay, getting more out of your HT. Top three things: antenna, antenna, antenna. That's probably the biggest weakness, right? I always say rubber duck is a very convenient, crappy antenna. And so it's good for what it does, but you'd really like to improve that. I think from the technician class, you know, we always talk about going longer. People sometimes get one of these, which is a quarter wave on 2 meters. That's not too bad. But what's actually a ton better is a half wave. Okay, so this is the, I forget which brand of half wave antenna it is. There's several out there. This works like way, way better than a rubber duck, but it's a little less convenient, right, if you're carrying around. But then, so that's the next thing you do. And then, of course, there's a mobile antenna. And we always talk about mag mounts are an easy choice to plop on top of your car and run the cable on in. And that cable attaches to the antenna jack on your radio. So you can do all that with an HT. You can actually hook an HT up to a base station antenna as well. That'd be another trick to use. So keep that in mind. Yeah, there's my favorite half-wave. That's actually an MFJ half-wave, pretty good antenna. I recently discovered a dual band version that comes out of China, and it's they're available on Amazon for $17 shipped to your door. I'll pass this one around. It actually works surprisingly well. Works on 2 meters and 70 centimeters. Okay, so that's a little bit about HTs, but then, you know, what's the next step? The next step is, and we're going to talk about it at your home, right? Next step is set up a home VHF station or a base station. And really, there's three main pieces of equipment you have to put together. You need a DC power supply. Of course, that plugs into the wall, right? Takes 120 volts AC and then turns it into 13.8 volts DC. And so we hook a DC cable up to our transceiver. In most cases, we're probably going to go ahead and get a mobile transceiver, right? And we'll just, instead of hooking it to our car battery, we'll have it at home and hook it to a DC power supply. And then we have to run some coax out to some kind of antenna. And the antenna is as the name says, is typically going to be a vertical antenna. So if I put that together, those are the key elements of a basic VHF station. So let's look at the power supply issue. You know, sometimes people call these things 12-volt power supplies. They're actually set for about 13.8. That's actually what most radios like to see. My recommendation is look for a brand that actually is made for use with radios. There's lots of power supplies out there, but there's a number of them that are specifically designed for use with transceivers, whether they're ham or commercial or whatever. There's two basic designs that you'll hear people talk about. There's linear or switching design. This one here happens to be a switching design from Astron Power Supply Company, and it's pretty nice little unit. Puts out 15 amps continuous, so it'd be good for your typical 2 meter, 70 centimeter mobile transceiver. The big difference between linear and switching is the linear power supplies have a big honkin' transformer in them that makes it larger and heavier. And it used to be people would say, well, for radio use, you really want to have a linear power supply because there's no switching noise that's going to interfere with your radio. But over time, all the power supply manufacturers, again, if they're focused on power supplies for radio use, have done a good job of limiting the switching noise, and so that's no longer an issue if you buy from a reputable manufacturer. So I pretty much only buy switching power supplies anymore. Something about like this. And look how light it is. If this were a linear supply, I probably couldn't hold it in one hand. It'd be like 4 or 5 times heavier. And then the question is, well, you know, the voltage is going to be a fixed voltage, right? You only need, you want it to be 13.8 volts, and you want it to stay there all the time. But the question is, well, how much current do I need? Well, the obvious answer is you need enough current to supply your transceiver. So you go figure out what kind of transceiver you're going to buy and look in the manual, and it'll, typical FM VHF rig will probably draw out, 10 amps or something like that. So you might get a 10 amp supply. But actually, this is probably a case where you might want to buy a higher capacity supply for future use. And so maybe up to like 20 amps, because 20 amps doesn't cost you a ton more than 10 amps. And I'll give you an example of that. So here's the Astron SS25M. It's a really nice supply. It's a little bit bigger than the one I have here. It's probably another 3/4 of an inch tall, and maybe a little deeper. But it'll run 20 amps continuous and up to 25 amps intermittent. That basically means if you transmit and draw 25 amps for a short period of time, it's fine with that. But if you did a key down and kept it on all the time, it'll probably cut out at that point. It's about $140, pretty good value. This particular one has the meters on the front. That they have models with and without meters. I like meters. It's kind of nice to see what's going on, see what the voltage is doing, and then as I transmit, I see how much current I'm drawing, that sort of thing. Not really required. And again, why would I want a little bit higher capacity power supply? Because if I come along and I put like a second radio in the ham shack, I can go ahead and add that to a high capacity supply. It'll probably handle both of them just fine, especially on receive. Receive's usually low current. It may not handle both of them on transmit at the same time, but you'd have to check the specs on that. But it gives you a little more options going forward. Okay, so let's talk about transceivers. And this again, we're kind of in that FM category. I think there's 3 basic classes of transceivers. You could go 2 meter FM only. This particular one looks like I've once again, I'm showing all Yaesu equipment. Sorry, Icon and Kenwood and Malenko, but I think I've tended to purchase Yaesu and been pretty happy with them, but Kenwood, Icon, they're kind of, and Yaesu are considered the big three, and then we'll talk about some of the Chinese manufacturers as well. Anyway, the basic thing is 2 meter FM, and I think I've got such a thing here. I'll go ahead and pass this around. Here's a slightly older 2 meter rig from Yaesu. I think it runs 50, or this one may run 70 watts, I forget. So single band. Then the next click up is, let's get 2 meters and 70 centimeters in the same radio, but still with a single receiver, and that rig there is about $265, pretty typical. And then the next click up from that is a dual receiver radio, which I think is pretty nice, because it's kind of like giving you 2 radios in one, so you can, maybe have one side of it listening to your favorite repeater, and the other side listening to 146.52, which is why I do run it down the highway. I usually leave one frequency always set to 5.2, so that's kind of a nice plus. So those are sort of the three main categories. My recommendation around Colorado is I definitely encourage you to think 2 meters and 70 centimeters. Some people will argue, hey, 2 meters gives you access to all these repeaters, that's plenty, and that might be true, but the extra cost to get to 70 centimeters is not too much. And there's a ton of 70 centimeter repeaters. If you look at kind of like where are the repeaters in Colorado on what bands, if you cover 2 meters and 70 centimeters, you've got the vast majority of the repeaters, so it puts you in pretty good shape. You could choose between either single receiver or dual. That's kind of a personal choice. And then I said, then consider other features, and we'll come back to that, because there's these radios I've shown here are all pretty basic, and the manufacturers keep coming out with more and more cool stuff on top of that. Yeah, again, 2 meters, 70 centimeters, and if you've forgotten, we throw those words around pretty fast, right? So 2 meters is 144 to 148 megahertz in frequency, and 70 centimeters is let's call it 430 to 450 megahertz. Okay. There is one other category. This is Chip's favorite. These what do I call it? The mini transceivers, and these are mostly from China, but they're more compact. I have one here. This one actually happens to be a TYT, and they vary a bit. They almost always have 2 meters and 70 centimeters. Some of them have tossed in like the 220 megahertz band, or maybe some other bands. They may run a little less power, like some of them are 10 watts, some of them are 25 watts. 25 watts is probably plenty. It's probably not a big deal. And they're, as I said, they're pretty compact. So let's see. Go ahead and pass this one around. And guess what? They're less expensive. So $75. And you go, well, what's the catch? What's wrong with them? I think really the only thing I've noticed is the receivers are not quite as solid. They're more susceptible to interference. So say you were going to use it on a mountaintop. Oh, say you're going to take it to Cheyenne Mountain and do mountaintop operation. I would not recommend taking the Chinese radio. Okay, what about all those other features? Because if you start scanning through the through the various models, you see lots of options. Other bands, 10 meters, 6 meters, and 220 megahertz is 1.25 meters. If it's an FM only radio, you're not going to get a lot of use out of that in Colorado. I wouldn't buy the radio just for that, right? And so a recommendation is these are fine to have but not required. APRS is a nice feature. That's this, and Vince was talking about that a little bit. It's that automatic packet reporting system, burping out your position and such. Pretty cool feature, more for a mobile though, right? If I'm just gonna be sitting in my house, I'm not sure you really are gonna care that much about APRS. And then probably the toughest one for me to comment on was digital modes, because there's all these radios I've been talking about are analog FM only. You're going to find that there are digital radios available out there, and it's actually a growing part of the hobby, particularly DMR. And what's happened is in Colorado, DMR seems to be growing at a ferocious rate. D-Star is still around and is being used, so I wouldn't discount that completely. And then Yaesu has their own version called Fusion, and that's not, there are not very many Fusion repeaters in Colorado. If you go to a different part of the country, you may find a different experience. And I was talking to one of my buddies that teaches another license class, and I said, what should I say about digital? And what we finally got to was, probably for more of the most beginning hams, you probably want to figure out what analog FM is all about first and how all that works. And maybe a little early to jump into digital. If you're really technically savvy, you might want to go ahead and make that jump. And so one thought is, maybe you get like a nice mobile for installation at home and just get a handheld DMR radio to sort of start dabbling in DMR. So those are my thoughts there. Been talking mostly about FM only. What about all mode? Because I think if what I personally found is I've really gotten into this VHF thing, and it didn't take me very long to start to want to do single sideband, CW, FT8, all that kind of stuff. And so if you think you might end up down that path, you might want to think about an all-mode transceiver now. The bad news is there's no all-mode VHF, UHF radios. You can't call up Yaesu and say, hey, remember that 2-meter radio that does FM? I want the same thing, but I want it to do single sideband and CW. It doesn't exist. The good news is there's this thing that I just call the do everything radio. It's kind of like they give you the HF bands for free. You buy the VHF band, and these things are a really nice value. I mean, they cover all the HF bands, 6 meters, 2 meters, 70 centimeters, and they do AM, FM, single sideband. People use AM? Yeah. AM, FM, single sideband, CW, all that stuff. And the example I pulled, sorry, once again, it's a Yaesu, it's an FT857. For $850, you can get that radio. And that is an excellent value. ICOM and Kenwood both have similar kinds of radios. And so that's an option, but you're and it actually sets you up quite nicely for HF operation that Stu's going to talk about. So
is this the one that comes with the automatic tuner, antenna tuning? It connects directly to its own antenna?
The antenna tuner is not built into this radio, but it supports external tuners.
Okay.
And Yaesu sells a antenna that has a tuning mechanism that automatically is controlled by this thing. The other one to think about is the one, I've got my radio box back there that's got 3 different radios in it. The FT991 is kind of like this, and it includes a built-in antenna tuner. So, again, I'm talking Yaesu products, but ICOM and Kenwood have similar kinds of things to consider. It's all good. Oh, I did lie. There is one all-mode transceiver, VHF transceiver coming. They promised it for over a year now, and it's gonna be here soon. It's called the IC 9700, and if you're familiar with the IC 7300, really cool radio from ICOM, about that big, actually about as big as that 991 back there. Does HF through 6 meters, and this is going to be its I don't know if it's a big brother or a cousin, but it's higher in frequency. Covers 2 meters, 70 centimeters, and 23 centimeters. And so it's going to be a bunch of money, though. I don't know. They haven't announced a price. I'm going to guess it's going to be well above $1,000. Might be getting up around 2K. I really don't know. So again, if you said, hey, I want to do some of that satellite stuff, I know I want to get on 1.2 gig at some point, you know, you might start thinking about that, but that's probably the exception, right? I wouldn't point a beginner to that radio.
If they had 1.2 gig satellites, and you'll avoid the pileup because not very many people can work it in.
Yeah, right. I've worked, yeah. Okay. Back to antennas. So we talked about transceivers, talked about power supplies, now antennas. Polarization, we've already talked about that earlier today. So a key thing is basically all FM activity is vertically polarized. So FM, DMR, D-Star, any of that stuff. Now why is that? Well, it's naturally omnidirectional, right? So that's cool. I put a vertically polarized antenna on my HT. It kind of works quite nicely. I do the same thing on my car, right? Plop that on my car. Base stations, it all works pretty well. It just fits in pretty nicely. If you're interested in that single sideband CW and then all of that weak signal stuff, that is almost exclusively horizontal polarization. You can get better performance that way with directional antennas. You're going to tend to have directional antennas in that case. There are some omnidirectional antennas available too. I'll show you a couple of those real quick. But what happens is this kind of pushes you into a much more serious antenna installation, because if you have an antenna that needs to be pointed, you're probably going to need on your house, you're going to need some kind of rotor system to move it. So it starts to be a pretty big deal. So really, when we're talking FM, VHF, UHF, we're talking vertical antennas. So let's look at some of those. Here's some real popular ones. There's a lot of antennas out there. The Diamond X50 actually have one outside on a little tripod you can look at. It's a little over 5 feet tall. It covers 2 meters and 70 centimeters. It's got, I forget the gain spec. I started looking at gain specs on these things, and I found a lot of inconsistencies between manufacturers. I didn't really trust most of the numbers, but you'll get some gain out of that antenna. Pretty popular one with our various club members. Arrow has they call it a GP 14640. It's basically I don't think it's that tall though. I think that may be an error. It's basically a quarter wave ground plane antenna. You can see the radial sticking out. And he added a little element on there so it also works on 70 centimeter. You heard Adam talk about the J-pole antenna. So you could use his information to build your own. So that's a pretty cool idea. Various people sell them as well. This one happens to be the Arrow, and made by the Arrow Antenna Company. It's kind of made out of basically metal rods. I think they're probably made out of steel. They might be aluminum. And actually, the picture didn't quite show the whole thing, so I added a little extra stick on there. That's about 58 inches tall, and a good basic antenna.
Do you know what gain that J-Paul has made by now?
Yeah, so that's gonna, again, it's gonna be a half-wave radiator, so it's gonna be 0 dB compared to a dipole.
Because the Diamond X50 does have a fairly decent gain, doesn't it?
It's got a few dB a gain, yeah. I think they said 3 dBd, I think. And then this guy, since it's basically a ground plane, would be equivalent to it's a quarter-wave ground plane equivalent to the J-pole. Okay, back to horizontal antennas, you can get them. You can get them in an omnidirectional format, but you can see what happens is you end up with this loop kind of structure. So it's not quite as convenient to mount, but it will work. So that's one option. But more likely, when people go horizontal, they tend to start looking at getting some gain. And so here you have 9.6 dBi gain from, that's the M Squared Antenna Company with a 4-element Yagi. So it's kind of a short Yagi. It's maybe, 5 feet long, something like that. Then here's a bigger one, 14.1 dBi. But so things start to get more serious here. In fact, they make some pretty long Yagis that can get you lots of gain, but you're gonna have to start, putting a rotor system in to take advantage of that. Oh, and then here's Yagi over here. Anybody know who this is?
Yagi Bear.
Yagi Bear.
Yagi.
That's probably a trademark violation. Sorry. Okay. And then, let's talk about mounting. So where are you going to put these things? So, we live in a world where there's all kinds of restrictive covenants and all that kind of stuff. So one thing you can do is do an attic mount of an antenna. And I thought this was pretty clever. You see what he's done here. He's taken a mobile antenna, probably 2 meters, 70 centimeter, and plopped it down on a piece of sheet metal. What am I going to have to worry about with that sheet metal? It needs to be magnetic, right? So aluminum's not going to work, so it needs to be steel. And he just put it up in his attic, and it probably works just fine. Here's another attic mount. That's a Comet GP3. It's actually very similar to that Diamond X50 I mentioned. And you can see he kind of, shoved it up into his attic as best he could. And then, here's a Hustler G6 270. That's a little bit taller. I think it's probably 6.5 feet tall. And that's on my house. That's a 2 meter, 70 centimeter. And if you look closely, it's on the same tripod as my mangled TV antenna. Turns out the roofer sort of mangled my antenna. But it just mounts on top of that, and that's kind of a typical mounting scheme is use the same tripods, TV mast, and hardware that people are using for over-the-air television. And then here's one of the best mounts I've ever seen.
It's an awesome amount.
Have you seen this in
I've
person?
seen this one, yes.
So this is Dan's N0OLD back there, and he did kind of a custom mount. You can see that he decided not to stick it on the top of his roof line. He sort of tucked it in along the eave, but he built this wooden bracket to sort of come out and get his antenna a little bit above the gutter there. So it actually looks pretty nice and works well too. And that is a Diamond X50A. Okay, what about grounding? Somebody asked about grounding earlier, and I'm going to let Stu talk mostly about this. The problem with grounding, it's like this can of worms. Once you open that can, we'll be here all day talking about grounding, and we'll be here all night, and maybe part of tomorrow, and we still won't have it all solved because it truly is a complicated subject. But I'll just start with, yes, I'm in favor of grounding antennas. Now, why is that? I think there's I'd say there's two main reasons. One is, even without a bunch of storms and stuff, even with just wind, you can get static buildup on your antenna, and you can get significant voltage showing up on the transmission line. So at the very least, you want to shunt that charge to ground. You want to give any charge that builds up on your antenna a path to ground. You don't want it to end up like in your transceiver. So that's kind of principle number one. And then I think principle number two is, yeah, you can have lightning strikes. Whether, you know, if it's a direct strike, there's not a lot you're going to be able to do about that. You can protect as best you can. But there are a lot of cases where there's nearby strikes, and you'll get some amount of charge showing up on your antenna, and you just want to shunt that to ground as best you can. So the main objective is provide a path for charge to get to ground. And so, yeah, bare minimum, we talked earlier, run a ground strap from the antenna to a ground rod driven into the ground. Keep it short and straight. And you say, okay, that's the bare minimum. You can always add more and more and more, but that's kind of the minimum guidance. If you looked at Dan's installation, you'll see there's a ground braid running off the side of his antenna, and he's got it routed down to probably an 8-foot ground rod. What'd you do with it?
Ground rod right there.
8-foot ground rod. So pretty much direct to ground. If I was gonna, not that I ever criticized my friend Dan, but if you wanted to make, the only thing I don't like about this is a sharp corner is not optimal, right? It'd be better if you sort of angled it down, but other than that, that's a very valid ground installation. Again, satisfies that requirement of give the charge a path to ground. And we'll reserve all grounding questions until Stu talks, and I'll let him handle all those.
Thanks, Bob.
Okay, transmission lines. There's 3 basic classes of transmission line. There's little, medium, and large. And usually we refer to those as RG58, RG8X, and RG8. Honestly, those terms are so abused these days. They aren't. They used to be mil specs that had precise meaning to them, but now they just kind of mean really small, kind of small, and big. And so RG58 is what you're going to use for mobile installations. So it has a diameter just under 0.2 of an inch. RG8X is a little bit bigger. It's about 1/4 of an inch in diameter. I did some calculations. I said, you know, just a rough rule of thumb, you could use RG8X for up to 50 feet in length at 50 megahertz or below, and then maybe 25 feet in length at 146 megahertz. But really, unless you have a good reason not to, you probably should be looking at the RG8U style, which is pretty big, 4/10 of an inch in diameter, but it's going to provide your in all cases, it's going to provide your lowest loss. So if you have any kind of length on your coax run, you're going to want to pay attention to that. And so, and then the fourth thing to be aware of is in that RG8 category, so we're talking cables that are 0.4 inches in diameter, there are specific low loss cables intended for VHF, UHF. So if you look down through the specifications on these cables, you'll find that some of them will typically call it low loss, and they will have fewer dB of loss per 100 feet. And that comes into play as you go higher in frequency. So for VHF, UHF work, you're probably going to want to use the larger cable unless there's some reason you really have to go smaller. So let's take a look at some numbers. So suppose we were installing 50 watt, 2 meter, 70 centimeter FM transceiver. Let's say the antenna is on the roof of the house. So, you know, if it's two-story house, that might be, you know, 10 feet per story, plus maybe a little bit more. I said, let's say it's 30 feet of cable run. It's another one of those things where when you start to install things, you start to realize, oh, the cable's gotta go here, and it's gotta go there, and what you thought was gonna be a 25-foot run all of a sudden turns into 50 foot. So you may have experienced that sort of thing. We're using 30 feet. So I said, okay, RG58, and I looked up this coax loss calculator, timesmicrowave.com. It's really pretty handy. And so I plugged all this in. I said 146 megahertz and 30 feet, and said, okay, you're going to lose, if you use RG58, you can use 1.7 dB. It's kind of like 1.7 dB. How do I feel about that? It's not too bad. Let's look at 446 megahertz. The number goes up dramatically. Higher frequency, more cable loss. I'm going to lose 3 dB. How do you feel about that? Half your power is gone in the cable, and that's on transmit. Half the receive signal is going to be gone on receive too. So I'm not liking that much at all. So the first thing you can do is go to RG8. So it's a little bit bigger in diameter, and you can see the loss goes down. Loss goes down. 2.5 dB, still a lot of loss. So then I plugged in RG8. And then at this point, you just start ignoring 2 meters, right? And you say, okay, I'm going to focus on this one, so it's going to be bigger. And 1.4 dB. And then I looked up LMR 400 Ultra Flex, which is a RG8 style cable that's low loss. And now I get this guy down to 1.1 dB, and I'm thinking, yeah, that's pretty good. I'm gonna put that in. Make sense? Questions on that?
How much more expensive is the Ultraflex?
How much more expensive, you know? I should have looked that up. I frankly did not. Between RG8 and LMR 400, it'll be a little more expensive. I'm thinking the last time I bought something in that category, it was less than $1 a foot. Anybody buy cable recently?
It was 119 when I bought it.
119? Okay, so a little higher, $1.19 a foot.
And mine was very
So,
flex.
you know, you do 100 feet of that and it starts to add up, right?
Hey Bob, if you're gonna do just receive only, and you want cheap, that coax stuff, RG6 is 75 ohm, you're gonna get a little loss just because of the impedance difference, but if you're not transmitting in long runs, that's economical.
Yeah, that's a good point. So RG6 is commonly used on the cable TV, satellite, down converter feeds, that kind of stuff. It's really, really low loss, but it's 75 ohms. And so usually doesn't get used for ham purposes, but Vince is saying if you're doing a receive only kind of thing, you could go ahead and use that.
Question for you, Bob.
Yeah.
With regard to that 75 ohm, can you use that for both receive and transmit without getting into big trouble?
Some people will use the 75 ohm for transmit. Particularly what they'll do is they'll pick up this larger cable called hardline. And again, what Comcast and those guys use is 75 ohms, and sometimes you can come across surplus hardline from them, and people will use that for transmit and receive. I've never done that, but hardline is so much bigger; it has a lot lower loss, and 75 ohms is not that bad of a mismatch. Okay. Oh, coaxial connectors. So. Basically, all these radios are going to have SO239 connectors, right? This one, that's what this one has. That's what the mini Chinese radio had. So that means you're going to have PL259 connectors on the coax cable. The truth is, those connectors are not that great at 70 centimeters. They're generally considered okay for 2 meters. Some people actually quibble that they don't want to use them for 2 meters, but really an objective look, at 70 centimeters, these are not very good connectors. So you're kind of faced with, well, why did the manufacturer put that connector on there if it's not that great? Well, they're assuming you probably only have like 1 or 2 of those in the system, so it'll be okay. And people generally know how to use those connectors. So, so basically keep the number of connectors to a minimum. And yeah, we could spend a day on this too. You probably do want to learn how to attach those connectors. It's kind of a key part of ham radio. And some people like to crimp them, some like to solder. Those are both acceptable if you're using the right tools and techniques. And we'll probably save that for next tech day.
By the way, can I make a comment about, those connectors are really lousy. I mean, they radiate, they get radiated into, they're not weatherproof, they're just, it's really a good idea to spend the money, buy an adapter, screw it on the back of that S0239, convert to type N, and never look back. I don't recommend using those connectors outside. I mean, you can, but you're much better off spending the money on type N.
Next tech day, Mike, connectors, right?
I think you just signed up for that, didn't you?
All right, once you wire all this stuff together, right, we're gonna have our antenna, our coax, our transceiver, our power supply. You really ought to check the SWR on the antenna. I mean, you might get lucky and everything's fine, but I think you really need to check the SWR. So what's that? Standing rate ratio. Actually, Adam talked some about this already. It's a measure of the match of the antenna system to the transceiver. SWR of 1 is perfect, and then anything greater than 1 is less than perfect. I'd say rule of thumb is the SWR would be less than 2 for a typical VHF installation. I think there's really 2 things that can happen. Like take this X50A antenna, it has no adjustments. So in theory, it's tuned and you don't have to touch it. So if the SWR is too high, when you install that, get your cable and all that, then either the antenna is defective or you screwed up the cable or the connectors. So then you have to kind of go into troubleshoot mode of what the heck is going on and how do I fix it. The other case is what Adam described, is some antennas are intended, they have to be adjusted. Like when he described building that J-pole, he said, clamp that one conductor on, check the SWR. If you don't like the SWR, move it a little bit, check it until it's good, and then once you've got it in the right spot, solder it down. So it's kind of like some antennas require adjustment, some are fixed and you should never have to touch them. Okay, so how are we going to measure SWR? I'm going to hook a cable. I've got my cable going to the antenna, and I'm going to have a little jumper cable from my transceiver, and I'm going to stick my SWR meter in line. That's how most of these work. In fact, it uses the power from the transmitter to do the SWR measurement. And so you just get out the meter, follow the instructions, and it'll read out the SWR. The other thing to do, the other way to do it is hook up an antenna analyzer. And there's all kinds of antenna analyzers out there. This happens to be a Comet antenna analyzer that's pretty good. It goes up and covers the 70 centimeter band. And so you hook that up, and it's got its own signal generator built in. Pretty much just dial in the frequency, and it's got a meter that says, here's the SWR.
Are they transmitting while you're doing these tests?
See, that's the difference, right? When I use the SWR meter, I'm actually going to transmit to take the SWR reading. When I use the when I use the antenna analyzer, it has its own signal generator, and the transmitter is not involved at all. I'm just connecting that to the antenna and taking the reading.
So its signal maybe is so low that it doesn't.
Yeah, signal's really tiny. Yep. Okay, we're almost to the end here. I tried last slide here is like, okay, so why would I go to all this trouble? I got my handy dandy little HT, and I'm talking to people, and I'm hitting repeaters and all that, so why would I want more than that? And so I tried to give a specific example. So this is my home location. Now, you ought to know, I pretty much live on the top of Monument Hill. That's not totally true. I'm about 10 feet below the crest of Monument Hill, so I don't have a good radio horizon to the north. I have a really good radio horizon to the south. And so if I get out my handheld transceiver, I'm going to get, really, these things, HT to HT on flat terrain, it's like 3 to 5 miles. It's not a lot of range. Now, if I'm using repeaters in the area, oh yeah, I can access all the repeaters. There's a bunch on Pikes Peak, there's a bunch on Cheyenne Mountain, the N0LXF one we're talking about. I can hit all those with my HT, so I'm good there. Okay, I like to do summits on the air, so when our buddy Steve is out on Mount Herman, no problem, I can work him on Mount Herman. I can work people to show up on Pikes Peak. Squaw Mountain is a mountain west of Denver, think of it as west of Lookout Mountain and east of Mount Evans. I can't talk to Squaw Mountain with an HT. I can't talk to Mount Evans with an HT. Okay, so now if I have a VHF base station, and so I'm saying 6 dBd gain antenna to 25 feet, 50 watts. Now I'm talking to people simplex 20 to 25 people, 20 to 25 miles out. Actually, from my house, I got enough of the elevation gain. I can work like, people 40 miles away without too much trouble.
Bob, is that 6 dB antenna, a Yagi antenna that you've actually turned?
No,
Okay.
it's that
Is that-
antenna.
Okay.
So it's a pretty decent vertical antenna.
Where does the gain come from?
It's got multiple elements stacked up.
Okay.
It stacks them vertically.
I think
Okay.
the real answer to that though is that it's doing this. If you've got a omnidirectional pattern, right, a cone that it's doing all the way around, it's squeezing that cone down into a narrower cone, so the gain is relative to an isotropic photosphere antenna, if there were such a thing, a pinpoint that's radiating in all directions equally, from that sphere down to this cone that's going around 360 degrees.
So how does it compress it? I don't understand.
Well, it just concentrates the signal
Okay.
greater in that horizontal
Instead of
direction.
having one half-wave vertical element, it's got several vertical elements that are phased together to create that gain.
The phase relationships of the different elements that cause that concentration.
I gotta wrap up. So, and now repeaters with that thing, I can hit all the Denver repeaters. I can hit repeaters up in Boulder. I can hit a repeater on Horsetooth Mountain in Fort Collins. Okay, I can hit the Pueblo repeaters, and then they can still talk to Mount Herman, talk to Pikes Peak. Now I'm talking to Squaw Mountain. I've worked guys doing soda activation on Squaw, and Mount Evans is pretty easy to do. So just wanted to give you some kind of feel for what kind of difference that can make. And it's still FM and still VHF, right? And then, why is that? It's antenna efficiency, okay? So world's crappiest, convenient crappy antenna, right? So we have a much better antenna. I've got some antenna height, and I've got it outside. I've got it in the open air where I can really radiate better. And then of course I have higher transmit power. I'm running 50 watts. So, questions?
The X50, my experience with 3 of them have been that they are a much better UHF antenna than a VHF antenna. Have you found that?
I have not found that. I won't disagree with you. I don't know.
They have more gain at UHF
Yeah.
because there's more wavelengths of height to the antenna. That's, I don't know if that's what
Even
you're
though they're
referring to.
tuned on VHF, they don't seem to match up as well on VHF as they do on UHF.
Mhm.
And that Hustler antenna that you have is a similar antenna to the X50? Or is it a single band antenna?
No, it's dual band.
Dual band.
Yeah. I've actually done measurements on the Hustler when we were comparing different verticals. I was pretty pleased with what I saw on the Hustler antenna. I think physically, it's pretty solid. You know, that X50, people try and use them on mountaintop repeaters and they don't last. But for a home installation, they seem pretty good. Does that match your experience?
The Hustler, they will market that, isn't that the one they market as a repeater antenna?
Yeah, I think they do. Yeah. Bruce?
Diamond has two vertical heights besides the X50. Is there a 70 or a 30 one that's taller or shorter?
There's a 30 that's a little shorter,
Okay.
and then I forget the other one. Is it a 70? They've got some pretty big antennas. But I've never been a huge fan of those because they've got a joint in the middle, and I was always suspect that would be a weak spot. But you know, certainly not for a mountaintop location. Maybe okay for home use.
Does that telescoping that you had for the HT, does that connect to a FT60? Is that the same connector?
It's actually available in both flavors of SMA and a BNC, so you can get all three. And Stu's giving me the cut sign. I'm over
Okay,
time.
I got the hook ready.
Okay.
Yeah, I
We need to.
I just ordered that off
take
eBay for
questions
$12.
into the- Hey Barry, we can take questions into the break.
Oh, I'm sorry.
With Bob, and, cause we gotta get set up for the next, for my presentation.
All right.
And I wanna start on time, and we're 5 minutes late, so. Thank you, Bob.